Hello. Today we will be solving the very first problem on the physics test, where we must find the magnitude of the net force on the charge negative q prime. So, as you can see, we got... Oh boy. This will be a fun video to make. Negative q prime. The q... negative q, 3q. And this is root 3L. And this is L. The distance between these two is the same theta. It's hard to hold the camera and do it at the same time, but yeah, alright. So as you can see, since one is positive, one is negative, now right there's a negative charge, so it's going to be pushing away like that direction. This one's going to be pulling it towards it, you know, like that, in that direction. As we know, force on a charge is, of course, electric field times the charge. So, I should have done this on a piece of paper, but E net is going to be the sum of the electric field from E3Q plus the electric field from negative Q. Yeah. Of course, the equation for electric field looks a little something like 1 over 4 pi epsilon naught q over r squared, and then you substitute either negative q or 3q for that q there. So since this is root 3 and this is 3, when you square the root 3 it's going to be 3, and then the 3 will go over. So essentially the magnitude of these two electric fields are the same at that point. So the y component of the two cancel out, and you're left with only the x component of each. And since we have those nice thetas there, you know that this is sine theta, because it's the opposite over hypotenuse. So this is root 3L, it's going to be sine theta root 3L. Awesome. From then on, that means the total magnitude of the electric field from one of them is going to be sine theta, and then whatever charge you put in, you'd also put in the accompanying distance, which would cause this on the bottom to become L squared. I'm gonna make it an uppercase L, just so you don't get it confused with the 1, because that trips me up. So yeah, that is the electric field from one of them. As we stated before, the magnitude of the electric field is equal at this point, at the point of negative q, I forget, prime? Yeah. Okay, so then, since there's two of them, just double it up. 2 doesn't ask for the direction, but it's nice to keep things straight and say that it's going in this direction. So we have the... Oh, geez, that's a terrible 2. we have, that is the net electric field. At that point, we have this equation: force equals electric field times the charge at the point. Charge at the point is negative q prime. Since we're looking for magnitude, the negative doesn't matter. This just becomes q prime. It is important to note that you must put q prime there. If you accidentally mix it up and put q squared because you glanced at it too quickly, you will receive no credit for the problem and lose the full 15 points. So, in conclusion, that is the magnitude of the electric field of the force on negative q prime at that point. Circle and a smiley face. Yeah, good stuff.